Hi there. Today I'm just about to discuss something about traveling microscope, introduce all the basic theoretical parts and a very short video, and I'm just going to give you all the details that you want to know. What is a traveling microscope? Traveling microscope is a certain device. It comes from certain microscope. It's just a microscope. That microscope can increase the uh, magnify something, like if you're just about to observe certain small tube or something, then it'll show this tube like a very big one, like a it's like a well. Now it's a very big, so you can see it like a sort of pen tube, like a very big slant tube. That's the amount of magnification created by this one. So you can just create certain small stuff accurately, measure the radius and diameter or the height something. So this actually going to use in vast range, but everything is not going to do in this lesson. Actually, most of the stuff, the first thing you find is in um, optics. The second lesson, actually the third lesson, part of the third lesson, even 2023 students haven't learned it so far. It's like taking the uh, thickness and kind of you can measure the refractive index, this type of thing, using real depth apparent depth method, and measuring the Young's modulus of material, and measuring certain like surface tension. You don't even know what are these things. You are late in the A level, like in the very last things in your level career. So have a good look at. Now this one consists of a screw, main screw. Using this main screw you can just move the stuff upward. That means the all together, like the microscope and the readings, that it has a certain vertical reading, like here main vertical reading like somewhere around 50 14 centimeters, and the vernier scale, the vernier scale just moves with the microscope upwards. So you can just finally adjust using this one. And there's a tightening screw. Once you untie the uh, screw, you can just move stuff by manually, and the fine adjustment is done by this one. And this one too, just adjust the focus of the microscope. I will show you what is that focus and how to do it. And here the horizontal scale, is a certain centimeter scale, normal regular centimeter scale in a like a meter ruler, and there is a certain horizontal vernier scale as well. So this one consists of certain two directionals, like x direction and the y direction. Both directions you can get the coordinates of this one. It's a really useful device. The so there are certain levels, screw levels. You can keep it on a flat surface like a tabletop, and using there is a certain split level. Using a split level you can easily adjust this in perfectly horizontal position. And there's a screw to you to move horizontally even with a fine adjustment. Otherwise you can drag it using your bare hand. So these are the parts of the microscope, and this is the eyepiece, and this is the objective. uh, so this is the all, and let's see what are the applications. But I'm not going to teach you all the applications. They are up to future lessons. But if your teacher gives you a certain thing, like in exam practicals, like of a term test paper, so you have to face it. ඉතින් යාලා දෙනවා නම් අපිට කරන්න වෙනවනේ. So that's why I'm about to give it now. Okay, have a good look at. So the lower parts of the meniscus of a water level. So this one you don't get an idea, but have a good look at the observer. He just held the microscope in a certain vertical horizontal position. I will show you how to shift this in a horizontal position really easily. So have a good look at. Now just see, you can just turn the adjustment knob like this, and you can just hold the stuff in a horizontal position and observe whatever they are. So this is about a water only amount. So there is a certain meniscus. Actual meniscus is in a certain way, like so downward stuff, but you have to understand that all the time. So it creates images. So you are now using this fine adjustment of the screw. You can just create what finely adjusted stuff, and finally you can just get the actual reading on here. So it looks inverted because all the microscope, all the telescopes gives you inverted image, otherwise it's in upright direction. So this is how you finally heard, and you can just read the reading over there. It's like 7 point something. So the vernier scale is reading is 18. You can finally finalize the readings like this way: 7.7 plus vernier scale 18. So using that one you can get the result. Let me show you the reading again. Have a good look at main scale reading and the vernier least count of the vernier scale. I'm so 7.718 centimeter. In other word, 77.18 millimeter. So let's go back to the board again. So this part, have a good look at. So this is how you observe it. In the next one, so I told you something like taking the refractive index of a glass block. It is also a third lesson thing, optics. So no need to worry. So you can hold it and just move the microscope in a vertical position along the vertical movements, and you can check this type of stuff. There is a crosswire in the microscope, and you to take a capillary tube. Capillary tubes are like a very small tube with very small hole. That can be a glass tube or plastic tube. Very good example is a ink tube of a pen, regular ballpoint pen. The type of very small ones. Normally in lab you find glass tubes to do some experiments like of um, in surface tension, capillary reactions and those things, and these are up to be done in very last few lessons in properties of matter. Okay, let's move on to next part. So as I told you, you can just take these readings. Let me show you that in a video and come back to this position again and explain you. So have a good look at. You can move this up and down. See, the microscope can be lowered or moved up. So using this scale you can take the reading initial and final reading. And be aware of another thing, there's no zero error for traveling microscope. You only take the initial reading and final reading and the difference. Then now you can see it has a certain mechanism to move it sideways as well, like of the x-axis of the graph. So have a good look at using a needle, so you can see the position of that needle finally. And this is something like a experiment we do basically in surface tension. Now you can find out the reading 5 in the main scale and the vernier scale 14, and simply you can perform the results like in the same way. Okay? Main scale reading plus vernier scale reading times the least count. 5.25 is the main scale reading in centimeters, and 14 parts coincided with the vernier scale, and the least count is 0.001 in centimeters and 5.264 in centimeters. Really simple. Now as I told you, this is the way to find out the diameter of a capillary tube. This is how you hold. You have to hold the tube using a rubber bung, hold to a certain stand, and you the image is not clear. Now you can adjust the fine knob, adjustment knob, and using that adjustment knob you can just easily magnify it and get to the reading. So you have to hold it upper position and mark the reading, and once you take that reading, it's like a you took it like B, and just to move downwards and just get the reading. So there is a certain magnifying glass to you to read it clearly. This is what the upward reading, and you just mark it. So B, so just have to just use this type of stuff, and I've included that in the tube, and you have to raise it a bit because this is inverted. You are actually moving it upward, it appears to be moving downward. That is the position A. So you are just going to take the reading. That's why the reading is lower now. So 3 point, and you just get the 43 coincided with the main scale, so vernier scale. So your final reading is this one. Now you have to just get the difference, and you are not going to satisfy with only up and down motion because it might be irregular one even though it appears to be circular. Now you have to take the sideways. See, actually this is the right hand side, but it appears to be like the left hand side because of the lateral inversion created. So get the reading and tabulate over there and see, and finally move to the left hand side of that one. It appears to be your right hand. You finally get this, and you just get the AB difference. It's like a 0.12 centimeter, 0.06, and the surface tension is something different. You don't want to worry about this one because you don't know anything about this. So these are the future types of calculations that you have to make use of what? This simple thing called traveling microscope. That's it. Okay, let me just go to this part. So you can make this type of lateral motion, and once you move it, so have a good look at when you move it like this. So your crosswire, and there is a crosswire. Using this crosswire you can aim it at, so you can just simply hold it in this position and take down that reading. Again, just move this one to here, and it appears to be moving to the other side. So you can hold it to this side and get the other reading, and I accidentally just marked all that here. It should be this side, and you just get the difference. Like, so if they get this reading as A and this reading as B, you have to get the difference. So the horizontal reading is what? It's like A minus B. So A, if A has like an example 6.257 centimeter, you subtract that by the 6.052, so 6.052 centimeters. So what is the result? It's like 0.205 centimeter. This is how you take. So you don't want to worry about any zero error. There is no zero error for this one, as same as of the spirometer. But in spirometer we have to take the zero error initial reading like upward or downward and add or subtract. But here no need to worry, just get two readings and subtract and get the result. And in the next part, have a good look at. Now in this one, was it? Now I can just easily move this to here, like so. Now I'm going to move it upwards, and it appears to be moving to downward. So it is the if I take clicks like X, reading X, and I'm going to move it now to downward. It appears to be moving upward because of this lateral inversion. It's not inverted, actually the result is inverted. So now you may see this one. Have a good look at. Now it's moved up. You take the reading as Y. So the difference is the reading, vertical reading is what? X minus Y. This is how you take the reading. It's really easy to handle. There's no more hard thing here because this one has the adjustment knobs. You can unloose it, just move it upward using holding by your own hand and move it. There's a fine adjustment knob over there. This fine adjustment knob helps it to slightly move upward or downward, right? Very slowly. Like of the previous case, you saw that it's finally moving slowly. That's how you move it really slowly. We can come to this type of position very slowly, getting the result. And there is also horizontal adjustment knob. Even I'll explain you using this one here. You have a horizontal adjustment knob. You roughly move, and when you come to this type of position here, you can't just, if you try to drag it, it will just going to be really violently move. So what you have to do is you have to do it very slowly. You do it using this method. You just spin this one in a certain clockwise or anti-clockwise according to you to get this. So finally you hold it in a certain position in touch with this one. You might be really wondering why is that, because you know the certain theorem in circles. When circle, there is a certain line drawn to a tangent line is always perpendicular with what? Radius. These two lines are perpendicular. If this is the tangent, this is the perpendicular line, then it will just easily go through what? the center of the circle. So if you just move it to the other side, you have actually taken the diameter of the circle. If you don't understand this, just check your grade 10 mathematics book again and you'll see the results, and it's not a big deal. It's a really simple thing. So that's it so far, and I have to show you how it moves this type of upward and downward motion due to taking the that thickness difference of a glass thing. I'll just going to explore this in the optics lesson. You have to wait for more than 1 year because 2023 students even don't know this dot appears to be in a higher position due to something called refraction. I will teach that in the relevant lesson. Don't worry about that. So you have already know everything regarding this one, and there are some questions. An experiment is made to determine the radius of a capillary tube using a mercury thread and traveling microscope, perpendicular mass of mercury, particular mass of mercury, and electronic balance, watch glass. And you don't even know what these are yet. What is electronic balance? You don't know. And identify ABC of the parts. That's the only thing you know so far. And what is the initial adjustment of this instrument? You have to make it like perfectly horizontal using what? Adjustment knobs using what? Leveling screw. These are leveling screw, and you have to keep a certain water balance right here, and using that one you can just adjust it. And it's normally it is they are already default one, but normally if there is no other one, so you have to keep it and just balance it. Water level is a very small device. There is a small bubble of water there, and you can just have a look at of that one. When it's tilted, it appears to be moved to somewhere. If this tilted to other side, the water bubble goes to here. Water bubble only stay in the middle if the stuff is completely balanced. You can adjust these two knobs and just do it. Give a method to insert a mercury into capillary tube. You don't still know this method yet, so it's also a future lesson thing. So technically I can tell you, you can simply not be able to do any of these questions related to traveling microscope. Only thing you can do is you can get the release count and name the parts, and you can show the positions. That's it, nothing else. So no need to worry. So it's all what you need to know all about the traveling microscope. Okay guys, I think you understood this, and my aim is to quickly start the vectors lesson. Vectors is a really essential lesson. That's where real physics begins for A levels. Actually so far we have done something really bullshit. Sorry for using this word. Actually it's a bullshit. It has nothing. So we were just spending a very bad time. Because why? Useless lesson, but they have included. So they give big questions, but actually useless. Even the technical college students know far better than these things than us, because they are the ones they use it. In technical college you get a practical stuff, and it's actually good subject. I'm not just condemning it, but for A-level students actually these things are just to introduce, but in Sri Lanka they go way beyond that. That's just why we have to study. Now we have completed, so in future we are just dealing with really numerical and mathematical physics. So stay tuned. God bless you guys.